Hello, I am Julien Gagneur from the Technical University of Munich. Predictive models are catalyzing progresses in genomics with applications spanning raw data analytics such as variant calling, but also bioengineering and genotype interpretation. However, and in striking contrast to previous efforts to share data or libraries and software, the genomics community has mostly relied on individual solutions to share trained predictive models. We argue that the FAIR principles also applies for trained predictive models. To address this need, we have initiated Kipoi, a repository of trained predictive models, together with the labs of Anshul Kundaji and Oliver Stegle. Kipoi models are simply shared as a YML file describing the trained model. Trained models consist of a model component, a parameterized mathematical function which can be implemented using a variety of ML frameworks, thereby serving the genomics community rather than specific developer communities. Model architecture and weights are stored on data repositories like Zenodo, ensuring immutable and long-term access. Models come along with data loaders, which abstract and unify the preprocessing of data stored in bioinformatics file formats, yielding numerical representation that can be used as model inputs. We use Conda to manage dependencies. Models are subjected to nightly tests and test on merge request using a continuous integration service, thereby ensuring that all models are executable and yield reproducible outputs on test datasets. General model information, including a simple application classification, facilitate the browsing of models on the repository website. Each model is stored on Kipoi's GitHub repos. As of today, there are 28 model groups covering over 2,000 individual models across various genomics areas. Kipoi models can be accessed via Python, R, command line interface, or as Docker containers. Typical applications include seamless benchmarking of models. Here is an example for comparing transcription factor binding predictions across various models, which is achieved with a generic command line. Another very much needed application is genomic variant interpretation. This can be achieved in a quite generic way by leveraging Kipoi's variant effect plugin. For modelers, transfer learning is an appreciable application whereby new models can be quickly built starting from related Kipoi pre-trained models. Last but not least, building ensemble models, for instance to score variance by combining existing models, can be quickly done thanks to Kipoi standardized data loaders. We keep updating and populating Kipoi. We are also running a monthly web conference on deep learning for genomics. Visit kipoi.org for details. In conclusion, Kipoi is implementing the FAIR principles for trained predictive models in genomics, which we hope will help the community to collectively build better genotype to phenotype models. Current and future development include expansion of the repository and better integration into bioinformatics infrastructure. Here are the people who contributed to this work. I thank you for your attention.